You're here because you want to master chemical formulas with a University of Cambridge graduate. Let's begin. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today.
So the first kind of chemical formulas that we want to look at is for our ionic compounds, right? So remember, ionic compounds consist of cations, which are positive ions, and anions, which are negative ions, right? And if you follow these series of steps, right, you will no doubt be able to get the formula for any ionic compound. So step 1, you want to determine the charges of the cation and the anion in the ionic compounds first. Right, so hint, for single element ions, right, you usually refer to the periodic table to predict the charge. So for example, in group 1, for example, right, they tend to have a fixed charge of like a +1 charge, and then in group 2, they tend to have a fixed charge of like +2. And if you look at your non-metals, for example, okay, if you look at group 7 or 17, for example, okay, you tend to have a -1 charge. And if you look at group 6 or 16, it's a -2 charge, and so on and so forth. So there's a whole trend in the periodic table that you can actually find out for the most likely charge of an ion. Then after that, if you have a complex ion, which is an ion with multiple elements, okay, you need to go and memorize them. So here, okay, I actually have a table over here which lists down those in asterisks, right? Those you especially have to memorize. Okay, so from here you can see there are some that you can predict from the periodic table. That's what I was talking about just now, where you predict from the group number. Okay, for example, sodium is a +1 charge because it's in group 1, right? And there's many more that you can also predict as well. Now the tough ones are the ones that you have to go and memorize, okay, those that are bolded, right, those with asterisks as well. So there are some special exceptions. For example, hydrogen is H+, silver plus, zinc is zinc 2+, okay, these are not very easy to predict. And then if you look at your complex ions, like for example the cation, ammonium is a very common cation. You have to memorize this, actually just NH4+, right, so go and memorize this. If you look at for anions, for example, same thing, there's stuff that you can predict from the periodic table, and then there's complex anions, right? Those are like carbonate, very common one, okay? CO3 2-, something you just have to memorize. So do spend some time, okay, after watching this video, okay, to go and look at this table and go and memorize, and then go and test yourself. That's just the easiest way to go and memorize your chemical formulas. So just a little in-depth into what complex ions look like. Okay, remember, these are just simple molecules that gain or lose electrons as a whole to form your ions. So if you look at your carbonate ion, for example, right? Okay, there's CO3 2-, so there's actually 1 carbon atom and 3 oxygen atoms. And what they're doing inside this ion is that they're doing covalent bonding within itself first, right? And the 2- charge means that it actually gained 2 electrons from another source, okay? And the electrons are usually given to the most electronegative atom. Okay, in this case it's O, but you don't really have to know that for now. Right? If you look at hydroxide ions, OH, there's covalent bonding between the oxygen and hydrogen atom, and 1 electron came from somewhere else and was given to the oxygen. And ammonium ions, right, is a +1 charge, so it lost an electron. Specifically, it is the nitrogen that lost the electron, and so you will have covalent bonding. The nitrogen can form 4 covalent bonds with 4 other hydrogen atoms. So as I've said just now, okay, so the ions will form electrostatic forces of attraction, so ionic bonding with other ions, okay, but within the complex ion itself, okay, just take note, there's covalent bonding inside, right? So for example, the C and O atoms are covalently bonded together in the CO3 2- ion, okay? So once we determine the charge of each ion, right, then we can do the crisscross method. Okay, so the crisscross method, right, is where you crisscross the charges. So for example, if you have Ca2+ and Cl-, okay, since calcium has a 2+ charge, right, you crisscross, okay, the 2 is given to the chlorine. And since chlorine has a -1 charge, okay, the 1 is going to go to the calcium. So as if there's a 1 over here, but we don't usually put a 1, right? So overall, the formula is just calcium chloride, CaCl2. Okay, so here are some examples of how we're going to work out the formulas for each of these salts, knowing that the ions are a particular charge. So for example, NH4+ and Cl-, all right, it's very simple, right? You're going to do the crisscross method, right? So if you crisscross this, right, if you crisscross, you realize it's just a 1:1 ratio. Okay, so you would just get NH4Cl. Right, now let's look at NH4+ and the O2- ion. So if you have this, you're just going to crisscross, right? So when you crisscross, you're going to get NH4 holding bracket 2, because oxygen has 2 minus, okay, and just a singular oxygen. Right? Next up, NH4 plus and N3 minus, you just crisscross, right? You get NH4, 3, N. Okay, we're just going to keep repeating this pattern itself. So NH4 plus and CO3 2 minus, you just crisscross, right? So you get NH4 2, CO3. And then we're going to have NH4 plus and OH minus. So again, you just crisscross, right? They're just in a 1:1 ratio. Mg2 plus and OH minus, you just crisscross over here. So just MgOH2, right? K plus and OH minus is 1 plus and 1 minus, so it's just KOH. Al3 plus and OH minus, so it's just crisscross, so there's going to be 3 OH minus ions here, right? This, all right? Copper 2 plus and carbonate ion, right? You crisscross is in a 2:2 ratio, but we don't normally put it like this. Okay, we always want to simplify it, right? We don't normally do this. It's not the way to go, right? Okay, so instead we can simplify this to make it CuCO3 right here. Next, we have H plus and CO3 2 minus, right? So if you crisscross, it'll just become H2CO3, right? So pretty straightforward when we know the ion. Okay, so now what if we don't actually know the ion, okay, and you're given like the name of the chemical substance, right? For example, aluminium iodide, right? How do we determine this? Well, the best way to do it is to identify the ions first, all right? And at a certain level, you should be able to identify the ion based off the name. Okay, so for aluminium iodide, we know there is aluminium ion and a iodide ion. And we also know this is an ionic compound because it's between a metal and a non-metal. So we use this method over here. So for aluminium, right, we know that this is a Al3 plus ion. And then iodine is an I minus ion. Okay, you can predict these charges based off their groups in the periodic table because aluminium is group 3 or 13, right? So it will have a 3 plus charge. Iodine is in group 7 or 17 in the periodic table, so it has a 1 minus charge. So in the end, it'll just be Ali3 if we do the crisscross method right here, right? Now let's take a look at our example. So barium nitrate. So barium nitrate is just, I'm just going to write this here this time. So it's just Ba2 plus. Okay, barium is in group 2 and nitrate is NO3 minus. This was a formula that you had to memorize from the table that we just spoke about just now. So for barium nitrate, we're just going to crisscross, okay, and we're just going to barium and then NO3 2, right? We crisscross like this. Okay, calcium phosphate, okay, this is Ca2 plus and actually PO4 3 minus. All right, this is another complex that you have to go and memorize. Calcium's in group 2, so it's 2 plus charge. So it's going to be crisscross. You're going to get Ca3 and then bracket PO4 2. All right, copper 2 hydroxide. Okay, this is Cu2 plus. Okay, this is something that you have to go and memorize. It's actually a transition metal. Usually it's Cu2 plus. It's also here that they tell you, since there's a 2, right, it has a 2 plus charge. Okay, and hydroxide is OH minus. It's something you have to memorize. So if you crisscross, you just get CuOH2. Next, iron 3 oxide. So iron 3 oxide, right, since there's a 3 over here, it's a Fe3 plus ion, and oxide is O2 minus, right? Oxygen's in group 6 or 16, so it's a 2 minus charge. Okay, so if you crisscross, it'll just be Fe2O3. Lithium sulfate is Li plus and SO4 2 minus. Li plus because lithium's in group 1, okay, so it's a 1 plus charge, and SO4 2 minus because you memorize the charge from the table on the left. So if you crisscross, you just get Li2 SO4. So now for lithium sulfide, okay, lithium is Li plus as we went through already, and then sulfite, okay, is a S2 minus, okay, with a sulfide. Alright, this is something you have to memorize also, okay, which is one of the very confusing ones, okay, it's just S2 minus. So if you crisscross, right, it's just Li2S. Next is lithium sulfite, okay, and from the name, okay, the main difference is that it's just Li plus and sulfite is actually the SO3 2 minus ion. Okay, but same way, we're going to crisscross this. It's Li2SO3. Okay, next example is potassium carbonate. Right, potassium carbonate is a K plus. Okay, it's in group 1, so it's a 1 plus charge, and then carbonate is CO3 2 minus, something you have to memorize. Okay, so if you crisscross, you get the idea, it's just K2CO3. Next is silver sulfate. Silver sulfate is a Ag plus ion. Okay, this is also something you have to go and memorize, and SO4 2 minus. Right, also something you memorize from the table. So if you crisscross, right, you'll get Ag2 SO4. Next is sodium fluoride. Sodium fluoride is just Na plus because sodium is in group 1, and then fluorine is minus charge because it's from group 7 or 17. So if you crisscross, it's just NaF. And then lastly is zinc dichromate. So zinc is zinc 2 plus, right? There's something you have to memorize. And then dichromate is actually Cr2O7 2 minus. This is another complex ion that you had to memorize. In fact, it's just right over here, right? So if you crisscross, again, since it's in a 2:2 ratio, we simplify it. So it's just 1:1. So it's just zinc Cr2O7. There we go. Next, we look at some formulas of acids. Okay, so for our acids, right, these are solutions with H plus ions. We kind of ran through this in our acid bases and salts, right? And the anion depends on the type of the acid. Okay, so our acids with our hydro prefix, right, actually contain the monoatomic anion, the ide of the respective element. So let's take a look at an example. For example, hydrochloric acid, right? Hydrochloric acid is H, and then chloric means it has the chloride ion. Okay, the chloride ion is Cl, so it's just HCl. Hydrobromic acid means it's H, and then bromic means it has the bromide anion, so it is the HBr, is the bromine anion. Then hydrofluoric acid is H, and then fluoric, so it's the fluoride ion, so it has fluorine anion inside, which is the F over here, right? Okay, next, acids that have no prefix and contain a ic suffix, okay, contain the molecular ions with an 8 of the respective element. Okay, so let's take a look at some examples. So sulfuric acid. Okay, so acid means it's a H. Okay, sulfuric acid means it has a sulfate anion. So it has a SO4 2 minus ion as well. Okay, it's H plus ion. So if you crisscross, okay, you'll get H2SO4 in the end. So you treat it like a ionic compound. Then nitric acid has a H plus and is a nitrate anion. So it is a NO3 minus. So if you crisscross, right, it's a HNO3 ion. Then carbonic acid, okay, so carbonic acid is a H plus and a carbonate anion, right? So it is a CO3 2 minus anion. If you crisscross, it is just H2CO3. Okay, lastly, phosphoric acid has the H plus and the phosphate anion, so it is PO4 3 minus. So if you crisscross, it's just H3PO4 over here. So that's how we determine the chemical formulas of these acids. Lastly, okay, we have acids that have also no prefix and contain the us suffix, which contains the molecular ion ite of the respective element. So let's take a look at some examples again. Your sulfurous acid, okay, has a H plus ion and the sulfite anion. So it has the SO3 2 minus ion. So if you crisscross, it's just H2SO3. For a nitrous acid, okay, it's H plus ion and the nitrite ion. Okay, nitrite is kind of a new complex as well. Okay, you have to memorize it from the table beforehand. It's actually NO2 minus charge. So if you crisscross, right, it's just HNO2. So you realize for your acids, right, you're going to treat it like an ionic compound, right? As long as you know the ions and you know the charges of most of these like complex ions, okay, you can easily determine the formula for these acids. Okay, so we kind of ran through all these chemical formulas for these acids over here. So pretty much like HCl is hydrochloric acid, and sulfuric acid H2SO4, nitric acid is HNO3. These are a lot of your common acids, and carbonic acid H2CO3, and then sulfurous acid is just H2SO3. Alright, so now we can look at the formula of covalent compounds. So actually covalent compounds are not very easy to predict, okay, but you can follow some of these steps over here to predict the formula for these covalent compounds. Okay, so step 1, you want to look at the groups of the atoms involved first, okay, and you want to find out how many electrons does the atom need to get a full octet structure. Remember, atoms go through covalent bonding, they share electrons, okay, so that they can get the full octet structure, right? And remember, for your covalent compounds, they have to share, okay, mainly because it's between a non-metal and a non-metal here, right? So that's how you remember this. Now, after that, you're going to crisscross. So for example, carbon, right, and chlorine, carbon's in group 4 or 14, so it needs 4 electrons to achieve octet structure. Whereas chlorine, okay, is in group 7 or 17, so it needs 1 electron to achieve an octet structure. So if you crisscross that, right, you'll get a formula of like CCl4. That's if you only have the elements, right, then you can kind of like predict what's the most likely formula. Okay, but sometimes covalent bonding will defy these expectations, so just bear that in mind. Okay, so here's a table which actually lists some of your elements, okay, with the formulas that you have to go and memorize. So for example, hydrogen, like hydrogen gas is H2, oxygen is O2, nitrogen is N2, carbon usually exists as a solid by itself, so it's just a carbon, and then chlorine is Cl2. Okay, your halogens are diatomic in nature, right? Bromine, iodine, Br2, I2. Ozone, right, is something you wouldn't be able to predict, but it's actually O3, right? And phosphorus is P4, sulfur is S8, right? So a lot of these, right, you just have to memorize them, right? It's just, they call it like general knowledge in chemistry. And then for compounds, right, water is H2O, right? You kind of knew it was H2O already because you just learned it from somewhere, right? And then ammonia is NH3, methane is CH4, carbon dioxide is CO2, sulfur dioxide is SO2. So sometimes from the name, right, you can kind of guess. For example, carbon dioxide. Carbon means you got C, dioxide means there's two O's, so CO2. Same for sulfur dioxide. Nitrogen monoxide means there's only one oxygen with nitrogen, so NO. Hydrogen peroxide is something that you just have to know, it's just H2O2. Hydrogen chloride is just HCl. Hydrogen fluoride is HF, and then ethanol. Organic compounds are a whole separate thing. Right, and we're going to teach you the naming for organic compounds in the organic lecture. Alright, so stay tuned for that. Okay, so let's practice writing down some of our chemical formulas for the compounds. So for carbon monoxide, we know it's a C and then there's one O, so it's just CO. Carbon tetrachloride is just carbon with tetrachloride means 4, chlorine, so it's just CCl4. Dichlorine monoxide means there's 2 Cls, okay, with 1 oxygen. Dinitrogen trioxide means it's N2 because it's dinitrogen, so it's 2 nitrogens, and trioxide means it's 3 oxygen, so 3 O's. Phosphorus tribromide, okay, it's phosphorus with Br3, right, because it's 3 bromines over here. Sulfur trioxide means it's 3 oxygen, so it's SO3. Okay, so if we take a look at our summary of what we went through so far, for our chemical formulas, we always divide it up into different substances. For elements, right, it depends if it's a metal or a non-metal. If it's a metal, generally, the formula of the atom is just as it is. So iron is just Fe, alright? It's just a metal solid right there. If it's a non-metal, it really varies depending on the bonding present. Okay, so this requires some general knowledge. As I mentioned, for example, argon. Okay, this is a noble gas and they tend to exist solely by itself. Versus Cl2, okay, it's part of our group 7 or 17. These are our halogens that exist as diatomic molecules. And then P4 and S8 are just covalent compounds with the formula that you just have to memorize from the table above. And then for our compounds, right, as we kind of run through, right, if it's ionic, we can easily predict the ions and its charges, and then we do the crisscross method, right? Versus our covalent compounds, we can't really always predict the formula of our covalent compounds. Most of the time, okay, you're going to have to memorize the formula. Otherwise, you can try to predict it from the name of the compound itself.
If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.